and welcome to Josef's Model Railway and Toy Room. Thank you so much for joining me. As always, you don't need to follow, like or subscribe. I'm just putting the videos out where I can and we're having a jolly good time doing it. 35 years in the making, I never thought I'd be getting to the point we're at now, and it's the bit I've been waiting for forever. A video that I can put up and in say another 10, 20 years time, keep looking back and just being amazed at what we're seeing. What are we talking about? Well, I'm talking about signals and wiring them to your turnout motors. In other words, when you have a turnout motor and you want to throw it over, you push the button and like magic it turns over and the signal will change from red to green. Ah yes, so many videos out there. Hasn't this already been done? Well, actually it has, but not in the demonstration I'm going to give you today. Of all the other YouTube clips that I've watched covering this particular topic, which are all good, don't get me wrong, they all fall down on one of the most important things, that when I actually pick the unit up and look at it and try and replicate what's happening, it's not that easy. So what we're going to do in this video is we're going to do a few key demonstrations in different ways to do this, but most importantly, we're going to bring that camera in nice and close and understand what is this bird's nest that I've created and turn it into, oh, that was awfully simple. Why didn't someone tell me how to do that? For those of you that have seen some of my previous videos, you'll be aware that sometimes there's a bit of a boring component and they go a bit too long. And in this occasion, we're going to tick all those boxes. So let's just get over the boring bit now and don't despair because there are chapters you can skip ahead as required. The first thing I want to just quickly talk about is I've purchased my particular signals from an eBay seller called WeHonest_CN, which I believe is an operation running out of China. And while I appreciate some of you have some rather extreme views regarding China-made products, it's the world we're in, and for the right price and the quality I'm getting, I'm exceptionally happy with what I've received. Let's take this particular signal. As you can see, it comes well boxed up with its appropriate mounting hardware. And if we just bring it in closer to have a look, this is a red and green searchlight signal and a pretty typical type of signal you would find around much of the world and particularly in South Australia where I grew up. What's so great about this is the entire signal is constructed from metal. So in other words, in a few years, we won't have to worry about the ladders separating from the supports as we see in a lot of plastic kits. This is some solid stuff that once it's put in is unlikely to ever need to be touched again. I also purchased some other signals at the time, and I guess it was also just to sample the quality of what we were seeing. Again, once again, another metal one with a 2-aspect red-green on board, and the LEDs have already been pre-wired up with our resistors as required. You will also see here another type of signal that could effectively just be sitting here over 2 lines. Again, we've got our red and green, red-green, red-green searchlight to cover 2 lines, pre-wired up, all ready to go. And this is a fully metal construction here. Fantastic stuff, and I think with a little bit of paint and a bit of weathering, we're going to end up with something quite nice. What I'd like to just say though is with this particular seller, I actually engaged them with some, as you can see here, rudimentary blueprints, seeing if they could possibly build some custom signal gantries to the specification I was chasing. The good news is they're more than happy to oblige, and construction for that is well underway. Next, let's talk about the types of lights that are used to illuminate model railway signals. And in the past, for years and years, we always had what was known as a grain of wheat globe. This is your traditional incandescent globe that once you apply some voltage to it, it would glow brighter and brighter depending on how much power was being fed through. And unfortunately, they did get quite hot, and you could only run so many on a particular circuit. As some of you may have seen on my previous airport video, I used a series of LEDs, and of course these have come down dramatically in price. You see them in all your Christmas lights and all of that. What's interesting about them is, unlike the previous globe, we do need to have a resistor soldered in on the positive leg to stop our LEDs from receiving some damage. What's great about this situation is we can take almost any power supply, whether you're running 15 volt, 12 volt, 14 volt, even in my situation here, a 9 volt battery, of which we can just pop in, sorry if I get it the right way, sorry about that. and we put it in and we've got ourselves a nice little light. And as you saw in that airport video, we can certainly string lots of these together and they remain nice and cool. So that's what we're going to be using. So that's the two types of globes that you may find on these signals, and let us carry on, shall we? The final bit I need to talk about, and you've seen in previous videos, has been where I'll make some connections using these WAGO connectors. Now in this particular layout, I'm not necessarily going to be using this for a lot of what we're going to do with signals. We'll have a series of distribution blocks and different ways of routing the wire accordingly, make the most of using the connectors on the point themselves. But I just want to take a moment because these ones come in various 2, 3, 4, and 5 configurations. The WAGO connector, we open up the little tag, we put our cable in or cables in, lock it down, and it's solid. And for a lot of electrical work that happens on houses now, these have become more and more common to be seen. I would highly recommend this, and your electrician may, and a tub of these may set you back $30 to $50 depending on where you are. So that can get a little bit expensive. But don't despair, because we're not doing 240 volts here or 100 volts. We're doing 12 volts DC. And in which case, for $12, you can get a lovely container which contains 2, 3, and most importantly, the 5-way connectors. And for what we're doing at $12 for all this lot, this is definitely the way to go. I'll also put a link of that in my description as well. Right, now the boring part's out of the way, let's get that camera zoomed in and have a look at what we're up to, shall we? Well, in most of the videos we have seen, we usually brought in on an angle such as this. But I'm sorry to say, this won't cut the mustard. We're going to need to get a whole lot closer. But just before we do, let's take a moment to appreciate what we're actually using here. We have got the DCC Concepts Cobalt Digital IP Turnout or Point Motors. What I have enjoyed as part of the investment of going down this particular track has been the support that I've gotten, even over something as simple as where I couldn't seem to get it to work because I saw all the blue lights illuminated saying everything's plugged in and working, and then finding out you need to push this button, and now, as you can see, now everything is working. But also, look at this comprehensive documentation you'll find. This came with the actual controller there, and with it are some excellent diagrams and some tremendous wiring diagrams as well. So when it comes to the actual turnout motors, you will indeed, once again, receive some pretty comprehensive instructions, and including some key wiring diagrams, as you can see here. Unfortunately, sometimes to people like me, it can be a little intimidating because we still have this world of people who are using INSULFROG layouts like me, and then the majority of more professional layouts that will use the ELECTROFROG. We're not going to cover any of that today, of course, but the point, what I'm going to say is, what I need to achieve is pointed out in this diagram, but if we just flick now to some additional DCC Concepts resources that can be found online, we get an even clearer indication of what we are supposed to be doing here. However, once again, this is still not complete. As a result, I'm going to be designing my own schematic to share with you toward the end of the video to show you where we are. And don't worry, it's very simple. And if you've taken away nothing from this part of the video so far, remember that blasted power switch on this box if you're using one. So now, let's get that camera even closer. We're getting closer, but still not quite close enough. But let's have a quick chat about these particular point motors. As mentioned before, I've purchased the club pack of DCC Concepts Cobalt IP Digital Motors. Here we go. So let us now take one out of the box and have a look at what we've got here. Well, it's quite simple. Here is our turnout motor. Now for those of you wondering, isn't there supposed to be an actuating arm that connects in and some mounting screws? Yes, there are. Now in the club pack, they're located in the middle compartment and you'll find all your mounting hardware as required. But we don't need any of that today because we're going to get our camera in nice and close and I'm going to talk to you about what we need to connect. What we have effectively here is 9 push-in terminals that we can connect to. And you'll notice here that 3 of them have been taped off saying switch wiring only. And for what we're doing, that sticker can stay exactly where it is because we will not be touching that whatsoever. Our focus, as explained in a previous video, was always just the first two. Once we've got our black and red feed to it, we can program it on the controller and away we go. But today's video we're going to be talking about the signals, so we need to do a couple of extra steps. So now we're going to get nice and close. Okay, here we are. This is about as close as I can get you in at the moment. So we've got our Cobalt Digital IP Point motor, or Turnout motor as some call it. And I've already actually attached the throw bar on there. You don't really need to do it for this process, but here we are. Let's just spin it around now and appreciate, as mentioned in the previous video, we've got our switch for programming, which this is number 1. And let's just flip it around. And as I said, there'll be a very clean, clear schematic at the end of the video that you can easily follow. But let's go through what we need to do. So in the previous video, you saw all we had was a black and red wire coming in to make this thing work into the first two here. The third one is for our frog. So those of you using INSULFROG points, you will need to use that. Let's just start right there and get this point going the way the instruction demonstrates. As mentioned in the previous video, we've got our feed coming in from the Cobalt Alpha box. So we've got our black and red lead. I'm just using a couple of these WAGO connectors so I can split the feeds out. This is a 3-way one, so you can see I could easily add another black and red lead and daisy chain and carry on to my heart's content to as many points as you wish to do. So here we are as per the previous video, and sure enough, if we apply some power, remember that sneaky switch, we've got the coming in, this is number 1, we should be able to push number 1, and away we go. I just want to quickly point out why I'm going black and red. As long as you keep it consistent with all the point motors, you'll be fine. I just go alphabetical, so B for black comes before R for red, and that's the format I've gone with. It doesn't matter which way you go, just keep it consistent and use whatever colors are best working for you. So that's our point working, which we established in the previous video. Now, according to those Cobalt instructions, we need to add our signal. I have a red and green LED here for those of you looking at them saying, hang on, they're clear. How on earth do you know which one is which? And these are just left over from the airport. I just put a little loop in the one that is red, so I know. Now, why are we not just using one of our signals at the moment? That seems like what this is all about. Yes, as most of you are aware, signals are not always the cheapest thing, and if something goes wrong, the globes are not easy to replace. So what I like to do to make sure we've got all this working, and that's why I'm here helping you today to do this wiring up, we're just going to use some standard LEDs. That way, if anything does go wrong, it's only cost me a few cents. Now, if we look closely at that diagram, you'll notice they're using a diode. And wouldn't you know it, here we go. A packet of 4 diodes that can be picked up for about $1. Ones we are using are ZR1004, which DCC Concepts inform me it's one of the most common to be found everywhere, and you are right. And according to our DCC Concepts diagram, what they've done is they've literally taken this diode and instructing us to insert it, and just pay attention to that polarity that's being used there as per their diagram. We need to have this running into the frog of our point motor. From there, we're literally just connecting the negative terminal of the LEDs up respectively. And the positive legs from our signal, or LED lights in this case, we just need to tap power from either the positive and negative. And believe it or not, what you can see right now is exactly what we're going to do. I'm going to attach the positive accordingly. Now, if your signal's going red to green or running in the wrong direction, all you need to do is simply swap the leads around depending on what you need. For the minute we don't have a signal, that's not a concern. We just need it to light up. So I'm just going to plug that in now and get the diode connected to the frog. I'll just plug this directly in there, but of course when you're doing your signal, you'll probably just solder some wire accordingly and connect this into the circuit as necessary. Well, well, it's a little bit rough, but you can see what we're doing here. So literally we're just piggybacking the positive end of our LED and or signal lights, once you've identified that, to the inputs of the turnout motor. And we send this diode up and then split it to come out on the negative end of our LED lights. This way, and as you can see, it's quite clear what we've done. And this way, when we do change our signal over, we go from a lovely red to green. And ladies and gentlemen, that's as simple as that's going to get. Well, that's all good and well and nice and simple. And I think for most of you, you can see exactly what we're up to and you'll literally carry on. Hence why I had a three-way splitter here. You can see how this stays contained within its own point arrangement and you can daisy chain and carry on. Based on the entry, it can get a bit tight here and it's easy to sort of short the connections out, especially when you're aggregating multiple cables. I think I may customize and build my own looms that will easily slot in and out of this to avoid that type of complication, and also because I know I'm going to need to factor in this diode accordingly. Ta-da! Now it's time to wire up a signal. Now why would we start with something simple when we could go with this? Now this is a surprisingly simple situation. This is just a red-green LED. It's truthfully not that complicated. In fact, between you and me, it's actually red, green, amber. However, we're not interested in the amber, so we're not going to use it. But I wanted to just point this out. When these do arrive, and we're going to do this one, this can all seem a bit intimidating, especially when it's not just one single one. Color combinations aren't always consistent. So what's the best way to know where to start? How do I know if I'm controlling this one or I'm controlling that one? Well, that's a fair point. This is particularly important if you're using grain of wheat globes. Don't just blindly start plugging things into a high-powered type of situation. In this instance, take your 9-volt battery and start probing. Now what I can tell you, because as you can see with this, none of this was organized. I literally just have a mess of wires that just come out of the base of the signal here, and it's up to me to figure it out. But it won't take you long because, as you can imagine, green is green, red is red, and there's always going to be a black. And of course, the amber one is our yellow cable here. Well, that's right. We don't know which one is which yet. So to start the process, we're going to get our 9-volt battery. As you can see, we already have the resistors already been soldered onto this. So these are LEDs ready to go. In this situation, black will be our positive. So if we just pop black onto our battery, and we'll take green. We're looking for green. Give me a green. Which one will be green? Will we get a green? So it's the one at the end. To which point I would basically twist these or group these together so I know what it's for, and I would indeed label them in the future. So if I need to know which signal is which, it becomes quite useful. This will be in its own separate video because my signal gantries come across 3 lines, so it will start to get a little bit complicated. Okay, the same thing, we've got to make sure we've got the right red as well. I say that because there's 2 reds and it's important you want to match all this up. So I'll try and get my big fumbly fingers out of the way. Remember, I'm looking at it the wrong way, so I can't see, but I do see a little flash in the corner there. So I'm going to say we've got it. So they are the leads we need. Well, now we've identified that this will be the signal we'll be focusing on in the demonstration, and this is what is known as a bicolor LED. In fact, truthfully, it's a tricolor. We're just worrying about bicolor because red and green are those 2 colors that we're only focused on. Common cathode or anode LED, depending on what you're using, it doesn't matter in the application. It works with either. Without getting too technical about that, the focus though is, as per our previous LEDs, each LED had a positive and negative leg on it. But of course, because we're mounted into the same spot, what we end up with is we have a feed for the green, a feed for the red, and then the common, or in what we're going to call the positive rail here at the moment. So that becomes a little complicated in the sense where our previous diagram goes out the window a little bit, because I can't just simply connect our diode up to the two negative legs. So what do we have to do to get this to work? Well, it's really not that difficult, and the diagram you'll be seeing at the end of the demonstration clearly indicates exactly how you're going to do it and what happened. Really, all we need to focus on here is we're basically reversing what we did originally. So in this instance, what we need to do is where we've got our positive and negative terminals, if you like, our red and black, what we're actually going to do here is on the red, in this instance, we're going to take the green wire and pop that straight onto there. And onto the black one is where we're going to have the red wire. As you'll see in the diagram though, I should have put red with red and green with the black just for a bit of color consistency. Truthfully, at this point, this has nothing to do with it all. And if you're running yard lights where you're using a red and amber or yellow situation, then of course, red can go wherever, and then you can use your amber light and then plug that in instead of where the green one is. So whatever you'd like to do. So these are what would have been the negative legs in the previous example. So what happens then in the positive situation? Well, once again, coming back to here, what we're going to do, we still have those original feeds coming in. And again, to keep it simple, I would have just put the red and green respectively in these holes. But as I said, those wires are quite hair thin. I don't want to manipulate them too much. And as I said earlier, I may come up with some custom loom to make all that work. But for the moment, let's just pretend that we've got the green and the red cable from the signal plugged into these first two. So with our frog, that's where we take the black lead from the signal, or the positive lead if you like, and then we bring that in. And what we need to do, we still have our exact same diode we've used before, but if you take a reasonably close look here, all we've done is just reverse the direction of it, as the diagram will indicate quite clearly. So everything is exactly as it was before. We've basically just reverse wired the way this is happening. And what sort of outcome can we achieve by doing this? So we have red here, which seems kind of appropriate because it's red on the panel. Again, if this isn't in the order you wanted it to do, all you've got to do is switch your green and red wires respectively down here. And I like that flexibility because you don't have to do any additional programming or any other complications. Let's throw that switch now. And as we do, you can see we've gone from red to green, and we can see that the throw arm has moved in the other direction. And ladies and gentlemen, that is all you need to do. In a double signal like this, if they were all going to be run from the same point motor, you can literally just follow it in and reverse the red and green to those connections. That way, as this one is going to go red, this one will be green. As you flick the switch, they'll just come over accordingly. And you can do this in any way you like. Girls and boys, ladies and gentlemen, thank you so much for watching. Look, I hope it's given you a little bit of clarity on what can sometimes be a little bit daunting. Everyone wants to get that magnificent look of signals and the beautiful glow that they do on a layout, particularly when we dim the lights down. And here you can see how simple it is, not just to wire them up to give them that wonderful light, but to actually create some movement when your points go from one side to another side. And just quickly, I do have that 2-aspect ratio here. And while you probably won't see it with the camera being that far away, but I just wanted to point out there are 2 green cables, there are 2 red cables, and then we obviously just had that common feed that goes in, which, as I've been describing, the positive one that I would feed into that part. But of course, we'll go into whichever way. With this particular type of wiring, there is no positive or negative, so to speak. Just stay consistent with your color scheme that you are working on. So from here, we're back to laying cork in our feature section, and the track work will keep carrying on. So thank you so much again, and we'll see you in the next one. Stay safe. Toodles. Ta-da! Oh, gets me every time. Thanks again, seriously though. As you can see from this bit of footage as well, this wasn't an easy one to shoot. I'm not very good with the close-up stuff. I don't have that kind of equipment. So you can see I just used a phone and bounced it back through to my laptop to give me a feedback screen on it. It's been an absolute pleasure though.